webinar on securing your workloads on Azure, and with me is Satya. So a little bit about the topic. So with the advent of cloud computing, public cloud providers like Azure, it's become very easy to get started on the cloud. But lots of times, what we have seen is people do not secure their workloads, and that leads to breaches, that leads to other kinds of pain. If personally identifiable information goes out, sometimes you might have people hacking in and running, like Bitcoin mining or various kinds of malicious workloads. So security should not remain as an afterthought, and you should get looked into before it's too late. So this talk will look at some of the guidelines to be followed when improving the security of the workloads, and we'll basically do a quick overview of all the different types of tools that are available on Azure, and what are the security best practices, so that when you start up building on Azure, it becomes secure by default. So a little bit about Satya before we start. So Satya is a seasoned SRE with experience spanning a variety of disciplines. He currently works at Adobe as DevOps engineer for Adobe I/O, which is Adobe's developer ecosystem and community. He has been working exclusively with containers and container orchestrators, such as Kubernetes and DC/OS. He's also written a book. He's the author of Practical Docker with Python, published by A-Press. So during his free time, Satya is also an avid blogger and has been blogging on Linux and technology for more than a decade. You can follow him on the internet at satyasays.com, sathysays.com, and he has also been a part of Stack Overflow, where he's very active since its private beta. We also have a social media challenge. What you can do is you can post about the event. You can post maybe screenshots of the webinar, any specific tip that you like from the talk with Satya, and please use the hashtag Scale Up Thursdays. So this is Scale Up Thursdays is a series of events that we are running as part of our initiative to educate startups to get better on various technical or business topics. And the best tweet that we find using the hash ScaleUp Thursdays, we will send you a swag bag from Microsoft for startups. So we'll also be taking Q&A in between the sections that Satya has in his presentation. So my suggestion is whenever you have a question, please post it on the chat as soon as possible. And once you post it, I'll try to reply as much as you can. And during the short breaks that we take, we'll answer the Q&A with Satya. And yeah, so with that, I will hand it over to Satya. So Satya, if you can start up and talk about the topic, so we can start off. Satya, I think you are on mute.
Video call, sir. So Vinayak, thank you so much for the introduction. Good evening all. Thank you very much for the joining on this Thursday. In the interest of saving some bandwidth, I'm going to be turning off my cameras, but feel free to leave your comments, your questions, and we will pick it up as we go through the slides and in between specific sections. Okay, so I'm going to be starting my slideshow, and you should be able to see my screen. Right?
Yeah, Satya, we can see your screen.
Okay. Okay. Thank you so much, Vinay. So we're going to be talking about securing workloads on Azure. I'll get into details a little bit. Vinayak has already given my introduction, so I won't be repeating this. But you can interact with me on Twitter. Satya Bhatt is my handle. You can find me on the internet elsewhere. But before we dive in, I'm pretty sure you would have seen this matrix, this image a lot. And I don't know how many of you actually understood this. I see this video, or rather, I see this photo being sent a lot. And they say that, hey, when you're on cloud, you're supposed to have the shared responsibility model. Now, I'm not sure I'm not sure how many people actually understand what the shared responsibility model is. So I'm going to be diving into this a little bit. But before we get into the shared responsibility model, let's have a quick reminder of what these PaaS, SaaS, IaaS means, right? So IaaS is your most difficult, or rather the most basic service. It's called infrastructure as a service. You would have used IaaS as Azure VMs, for example. It basically means that the cloud computing provider, in this case Microsoft, they maintain the physical infrastructure. You don't have to worry about the servers. You don't have to worry about the data centers and whatnot. You, as a customer, you manage the end-to-end deployment. You manage the end-to-end deployment from the OS to the application. So you need to take care of the OS patching. You need to take care of your application patching. You need to run your OS updates and whatnot, right? Next, we have the most common platform as a service, in which case the cloud computing provider, they manage the platform. So you think about something like Azure's managed Redis service. They manage the Redis platform. They manage the OS. They take care of the OS updates, and they take care of the infrastructure. You provide what sort of scaling and parameters do you want? What sort of what should be the size of the memory of your Redis instance, for example. You manage the dev tooling and the way the application interacts with it, right? So that's your definition of platform as a service, right? And then you have the next one, which is software as a service. It's generally pre-packaged software. Earlier, you would get software as shrink wrap back in the old days, where you'd get CDs, you'd install it. Now, as we move to the web, you have everything available as a web application. For example, Office 365, you don't need to provision it. The cloud computing provider, in this case, Microsoft, provisions it. They manage the application. You're still in charge of the application maintenance in terms of authentication, authorization, and things like that, right? So in general, when you look at the different PaaS, SaaS models and IaaS models, this is what the overview looks like. This is what the service provider will take care of. In case of IaaS, the service provider takes care of the data center, the buildings, the network firewalls, the servers and storage. In case of PaaS, they take care of everything, which is the servers, the storage, and they go one step ahead. They take care of the development tools, they take care of the operating systems and things like that. And when you go over and above to the next step, which is software as a service, the service provider takes care of hosted applications, apps, and whatnot, right? We're not looking at furthermore things like functions as a service. That's for a later point, but in general, this is what you would see, correct? Now let's look at the shared responsibility model again. I'm sure a lot of you would have started using Azure, be it as part of your office job or as your personal curiosity. Azure gives you a very generous free tier. You get $200 as credit, which you can use for a month. There are some things which you can use perpetually. When I started using the cloud, or when I started using Azure or AWS for that matter, right? I signed up, and then I saw that, oh, there's a virtual machine that I can sign up and spin up. I just went and clicked on it. I just clicked next, 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 next. I pretty much ignored everything, and that's what a lot of people do. They just ignore all the measures that are there, and they launch a new VM. They don't secure it, and then couple of days later, they see that their host has been broken into, or you've seen a huge bill being racked up. Why is it? It's because you don't understand the shared responsibility model. A lot of people have this misconception that just because you have started the VM, but still it's a VM on Azure's end, Azure will take care of that. That's the first fundamental misconception that we need to break down. So this shared responsibility model is what is telling you what you should be taking care of. In case of on-prem, which is your last year, you have to take care of everything, right? You have data centers where you have on-prem systems. You have to take care of physical hosts, the networks, this slide doesn't talk about electricity and backups, and you have to take care of that as well. When you're going into IaaS, the service provider takes care of the operating system, the network controls, the applications. Actually, the gray one is what Microsoft or the service provider will take care. So I was wrong. Blue is what the customer should manage. So in case of IaaS, you as a customer, you have to take care of the operating system, the network controls, the applications. When you move to platform as a service, PaaS, you see that there is a blur in terms of what is being used or what is being responsible. You see that network controls, it's shared between you as well as Microsoft. It's because Microsoft will give you the options of how you can secure your network or how you can secure your applications, but you still have to implement them. Towards the later slides, I'll show you what and all you can control and how you can control them. Okay. As we move towards software as a service, you will see that a lot of the responsibility has been completely absorbed. So that in turn reduces the overheads that you have, that in turn reduces the cost and the security and the compliance procedures that you have to maintain when you're running your own, when you're running software as a service. Okay. So what should you be looking at when you are securing your workloads? There are three broad categories. You can further classify it down to maybe 4 or 5, but I consider these are the three fundamental things. The first is identity and access management. Then the second one is infrastructure and application, and the last one is network security. I will not be going into a deep dive of every one of these because that will take a really long time. My last slide, we have references where you can go read up, and there's a lot that you can read. There's a lot of information on Microsoft documentation, as well as you have third-party applications, third-party websites where you can read up a lot about these. Network security is where I will go a little bit further deep in as compared to identity, because that's not really my strong point, but I will still let you know what options you have. Okay. We will take a break in between identity, application, and network security. These are the three ones. So we'll take a break across each of these so that it gives you a little bit of time to absorb in. And if you have any questions, we can take them up. Identity management, you have different options. The three main critical ones are subscriptions, multi-factor authentication, and RBAC. For someone who's new to the cloud, all of these seems a lot of mumbo jumbo, and I will try to make it easier, and I'll try to break down each of these. Subscriptions are at the most basic fundamental level, the lowest level of grouping Azure provides. So a subscription is equivalent to an account, for example. It's not quite one-to-one mapping, but still, subscription is basically a logical container for all your resources from start to end. Okay, so when you put your VM, you can't even, or rather, when you're starting up on Azure, you can't even do anything without having a subscription. Subscription ties in your payment methods, who the administrators are, and other things like that. Okay. When you're starting off with a subscription, or when you're starting off in the cloud, it's very easy to get into this thing where I'm going to create one subscription and I'm going to put all of that resources into that single subscription, and I'm going to use my resource group. Resource group is your next level of grouping, where you combine similar resources into a single group. When you're starting off with subscription, it's very easy to think like this is going to be a small one-off thing. It's not going to expand. But we all know business does not really work that way. Usually business expands and it goes booming. And getting your fundamentals wrong, where you put everything into a single subscription, is the most fundamental mistake that you can do. Why? Because moving your resources across subscriptions is not really something that can be done easily on a whim. There's a lot of thought process that needs to be applied. Furthermore, you will be putting your subscriptions broken down. They might be management level. They might be ways in which your organization has said that these are the different strategies in which These are different levels of separation in which we want our resource reporting to be done. So if you put everything into one subscription, not only do you have a mess that will be very difficult to clean up, you are also losing the most fundamental way of separating out your resources. There are different ways in which you can break your subscriptions. You can break it on the basis of workload, where you can say you have your your development workload in one subscription, you have your production workload in one subscription. You can break it down into your application categories. Whatever is mission critical, you can put it into one subscription. You can break it down as per your functions. All of my IT applications in one subscription, all of my my security applications in one subscription. You can have it as per your BO as well. All of your application or your organization will be broken into specific BOs. You can have one subscription for all your BOs. A BO strategy makes sense if your BOs are very small and not huge. Otherwise, you go into the same trap of having all of your resources in one subscription. The reason why is that when you log into Azure, like I said, the most fundamental thing is your subscription. So you select your subscription, and that's where you start working on things. And when you do something, let's say that you have a script which cleans up some of your older resources which are not in use. Now, if you have all of your resources in one, auditing this makes it very difficult when if you have a rogue script which is running, you would have deleted some important ones which should not have been deleted at all. You can easily avoid this by breaking your subscriptions into smaller chunks. You can also have this known as a mixed strategy, where you can combine all of these into separate things. This is a screenshot this is a picture that I have picked up from Microsoft's recommendation. Obviously, this is not the one-stop, just not the one-stop, the single common one or the one which works well for everyone. It would ultimately come down to you to decide upon which one goes well for you. But this is an example of how you can break down things. So in this, you can see that we have an environment level, which is further broken down into mission critical protected data, other production, your non-production into one. So that's how you can split it up. So which way is the best for you? That's something that I cannot give you. I cannot tell you this is the best for you, but this is the first step that you should take into consideration. The next thing is multi-factor authentication. I'm sure a lot of you people have heard of password breaches, and you have a lot of accounts and accounts, subscriptions, and whatnot. Most of the time, there's this option called MFA or multi-factor. Usually when you log into, for example, Gmail or Amazon, you just use your username and your password. Now, I don't say that I'm the definitive authority for passwords, but we've seen that a lot of people reuse the passwords, or they use extremely simplistic passwords. There's a lot of research which says that people don't really use complex passwords. They just say they use something like 1 2 3 4 5 6 or ASDF, or some of the common things like their date of birth. What multi-factor authentication does is, in addition to using your password, you also need to provide a second factor. Now, the second factor is not something which someone who's trying to break into your account will have easy access to. It can be something like a hardware key. I don't know if you've heard of YubiKeys. These are USB devices where you plug in, it acts as the authentication mechanism. A lot of you people, if you've done banking transactions online, you would have been familiar with the password and the OTP. So the OTP in this case acts as your second factor, where you enter your password, you enter username, and then the bank will send you an OTP. And if only your OTP matches, will they let you go through it? That's another example of that. You can also use biometrics, fingerprints, and retina scans, or things like that. For most users, biometrics and would be out of scope, I guess. Hardware keys are quite common, especially in large organizations, especially if they're using critical data. You'd see a lot of people having this RSA key, which has a specific number being rotated at a time. So Azure supports Authenticator app. Microsoft has got this Microsoft Authenticator app. So it will generate the keys. It will generate these one-time numbers, just as you see, just as how the bank sends you. Azure also supports the Oath hardware token. This is not the same as OAuth, which is a completely different thing. Oath is a reference mechanism that has been built. It's called It's a collaborative effort to build open authentication. These are similar to Oath hardware token. YubiKey is an example for Oath hardware tokens, right? Azure also supports SMS and voice calls. So if you try to log into your Azure account, it can prompt you to send an SMS with a specific code that you need to type in, or it can make a voice call to you, and you can say, yeah, I can go ahead with this thing. One thing that Azure does not support is if you're going to be using the third-party apps, like for example, Authy or 1Password, which has got its own one-time password thing. Azure does not support that. I hope Microsoft will add this feature soon, but you can use the Microsoft Authenticator app. So your question is, how do I implement this, right? So that's where this thing called security defaults comes into the picture. So Microsoft had a blog post about what they figured out and what they learned from a lot of their break-ins or a lot of usage patterns. A lot of people, to repeat what I said, a lot of people don't really go to great lengths. They don't even go to a decent lengths to secure their passwords. And so there's this option in your Azure portal called security defaults. What that does is, by default, it applies MFA for all users, which is fantastic, and you don't have to do anything. I just tried it out on my portal, on my application, or rather on my Azure login. I clicked on security defaults, enabled it, and that's it. I thought nothing happened. I signed out, and next time when I signed back in, it said your administrators applied security defaults, so MFA is mandatory. And I had the option of using the Azure Authenticator app, or I could use SMS, or I could use voice to sign in. And every time I sign in, I get prompted for this OTP. Security defaults are a very good way to get started with MFA, and it also adds some extra features, like it blocks all legacy authentication mechanisms. It blocks legacy applications which use older style of authentication. For example, legacy auth will refer to clients using older mail protocols, clients using authentication mechanisms which are not up to date in this current day and age. The next thing is conditional access. Conditional access is, you might say that MFA is nice and very handy, but what happens if I need to get in and I have an emergency? I have this emergency access account that I'm absolutely must use, which cannot apply. I cannot apply MFA. So that's where conditional access comes in. You can have a more granular level of authentication. You can provide user exclusions. You can have designated break glass or emergency accounts. And you can say with conditional access, if a user is logging in from this account, and if the user is from this specific location, then exclude that person from being hit with the MFA log. Conditional access, of course, can improve or reduce your security. So again, you should use this very carefully. You should not just just because your VP of IT cannot log in and says that no, I need access now, give it to me access now, doesn't mean that you go and add that person's username and account into exclusions. That defeats the purpose, because if the person's account gets broken, and then they have an easy way of getting it into your Azure account. Conditional access, it's by security defaults is free for all. Conditional access is not. So you might want to check in with your finance and security team. But I will not be talking about the pricing and tiers and whatnot. This is more about how you can use something which is there. I want to bring this to your attention that you have this feature called conditional access, which can help you make support exclusions easier. The next thing is role-based access control, or RBAC. Role-based access control is one of the most powerful things that I've used in terms of Azure security mechanism. It's not really easy to get to use in terms of there's a lot of conditions that you need to set up. But once you have it configured, it works really well, and it's quite exhaustive. So the whole principle of role-based access control is that instead of giving everyone access to specific things or all the things, you make specific roles, right? So you make a role saying a DBA group, or you make a DBA role, you make a network administrator role, and then you apply these principles saying that the DBA group can have access to modifying or to see. They can access only the databases, and you can make it even more fine-grained. You can say, I want an application A DBA group. Okay, you can go to that level. So there are three specific things when you're configuring role-based access control. You have roles. Azure comes with some default roles. They are owners, contributors, readers. As the name is self-explanatory, owners means they have full access. Contributors means they can manage, but they cannot be owners. They cannot add new people. That's only something which the owner can do. Readers are read-only stuff. You can have a reader role to say blob storage, and they can go and check your blob storage, but they cannot modify anything. Or you can have your own custom roles. You can say, like I said, the DBA group, for example, it would be an example of a custom role. So you have roles, and then you have security principle. A security principle in Azure is an object which describes a user, a service principal, or a managed identity. I will get into service principles and managed identity a bit later, but it's essentially a way of identifying specific resources, specific applications in Azure. So you can have a security principle which says this specific user, or this specific group of users, or this specific application. And then the next thing is you have scope. Scope is basically you assign a set of resources to which this access control applies to. Okay, so you have your group, which you have your role, which is DBA. You have a security principle where you identify specific individuals or specific groups of individuals. You add in your you say Azure's managed database service. So that is your security principle. And then you set the scope, and then you say that I will scope it to this subscription, or I'll scope it to this specific resource group. So you can go as fine-grained as you want. So this lets you have a very fine-grained access to any resource that you want. The disadvantage, like I said, trying to set this up can be challenging, but please do not give up on this. Spend the time, read. There's a lot of resources. There's resources at the end. Read up on a lot of these. See how you can best use this. And if at all you have a break-in, this sort of setup will really help you go a long way in this. Okay, so this is an example of how role assignment and RBAC works. So like I said, you have a role definition, which is owners, contributors, or you can have your custom ones. You have the security principles, which applies. So you can say that I have a contributor to, and for that contributor, my group of, or I can have a read-only group. I can have a read-only definition, and I can say this read-only definition applies to, say, my QA team, because they need read-only access to some of the resources. They have actions. They do not have actions to delete, to write. And you can scope it to this level. You can scope it at your management level. You can scope it to a subscription. You can scope it to a resource group, or you can scope it to individual resources itself. So that's how fine-grained you can get into. Okay. And this is basically summarizing what I said. You have groups. You can assign groups to specific accesses, and you can scope it to as narrow or as broad as you want. You can go it to all the way to management. If you have a development subscription, you can have a you can have an RBAC which says this RBAC is for dev resources, and you can group it to that subscription. Or you can have production DBA access, where you have a DBA which is they can have access to only 2 or 3 of these resources. And like I said, I cannot really guarantee, or I cannot tell you which works well for you. This is something that you need to think about. You need to have a plan of action for. Okay. The next step would be infrastructure security. But Vinayak, do we have any questions on this that we can take up, or can we proceed? I think we do not have any questions so far, so I'm going to proceed further. So we took a look at identity and access management. The next thing is what a lot of people would be interested in: infrastructure security. A lot of people don't really, a lot of people work a lot at the infrastructure level. So this is something that you would find in more interesting. Infrastructure security you can achieve at different ways. There are different aspects to it. I'm going to look at some of these, including encryptions, backup, securing your machine images, your container images. We're going to talk about Azure Key Vault a bit. There's going to be a little bit of demo on Azure Key Vault. And then we will look at virtual networking, which actually comes into the network security aspects, but we will transition into that. Encryption at rest. So Azure comes with Azure Disk Encryption, and the good thing that I realized about Azure when I spun up a VM is that by default, Azure performs server-side encryption for all of your managed disks with platform managed keys out of the box. So what this means is that when you have your workloads running on VMs, when they are saved on the physical instances, they are encrypted on the fly, and then they are written. So you don't have Azure does not, or Microsoft does not have access to your plain text data on the hard disk. So what does this mean? If someone breaks into a data center, it's quite unlikely, but you never know, right? You should take care of everything. But if someone does manage to break into a data center and steal some of the hard disks, those disks are encrypted by platform managed keys. In this case, Azure itself manages the keys, and they will encrypt them for you. Azure also supports customer managed keys using envelope encryption. What this means is that you can provide your own keys, and Azure will use that keys and they will encrypt it. And this is again not pure client-side encryption, in the case that if someone already has access to your virtual machines, or if they have broken into your virtual machines, they can read your data. But with CMKs, a lot of organizations want to know that the encryption is performed using their keys and not keys that others manage. The customer managed keys are encrypted using what is known as envelope encryption. So in envelope encryption, the storage service will encrypt your keys with their own keys. So when you change your keys, the actual data gets re-encrypted again. And the encryption is done using dmcrypt. Dmcrypt is a framework for encrypting your disks on Linux. And if you're using Windows, it's going to use BitLocker. The encryption keys themselves are stored in Key Vault. This is in case of customer managed keys, not in case of platform managed keys. In case of platform managed keys, you don't have access to them at all. Okay. If you want to go one step further, you can do your own level of encryption. In addition to using in addition to using customer managed keys, you can use something like Lux that's LUKS, where you encrypt your disks. This and this probably might sound basic, but I just want to reinforce that this is possible and you can do this. And I'm sure a lot of you would already be using this. If not, you should consider using that. Okay. Next, we're going to talk about blob storage. Azure Blob Storage is an object storage. It's also blob storage where you can store whatever you want. It's the equivalent of AWS S3. If you have a containerized application where you're storing user data, you can store that in blob storage. We hear a lot of data breaches available on public because they were available on publicly accessible S3 buckets. Blob storage is the equivalent of S3, and you can have your data encrypted. So the good thing is, as with disk encryption, Azure Blob Storage encrypts for all your accounts. It encrypts all your data by default using platform managed keys. You can also use customer managed keys where you provide your own keys, and they are stored in the Key Vault. And there's a third option, which is still in preview as of last moment I checked. It's called customer provided keys, where you can provide the keys for blob storage for specific parts. So if you want to use so when you're using a blob storage and when you're using customer managed keys, you're encrypting the entire blob storage for that using the singular key. But if you want to use different keys, you can provide your own keys with customer provided keys, and Azure will use that key and it will encrypt it for that specific parts, and then it's going to encrypt it on the fly without you knowing it. Okay. The disadvantage is, of course, you need to provide the keys. So if you don't have the keys that you originally encrypted with, you're out of luck. There's no easy way to decrypt encrypted data, but then that defeats the point of encryption, right? So backup. Azure Managed Backup lets you do backups of entire virtual machines. I have different thoughts about this. I don't know how many of you are familiar with this principle called pets versus cattle. When you're on cloud, your virtual machines should be what is known as cattle. This comes from the old farming adage where people are most likely, they are very attached to their pets. They give them names, they take special care of them. But in case of cattle, they don't really care about cattle because cattle is bred for a specific purpose. They are bred for milk, for meat, for sheep is bred for wool, and they don't care much about cattle. But you take very good care of your pets. When you're using your on-prem resources, you think of your on-prem resources more as pets. You take very good care of it. Excuse me. You take very good care of it. You have specific things that you've done. You have special handouts done for them. Correct. But in case of cloud, excuse me. In case of cloud, you should be thinking of your resources, especially your virtual machines and your containers, more on the lines of cattle, where if something goes wrong with it, you really shouldn't be spending a lot of time trying to make sense of what went wrong with that specific infra. And you should just be destroying it and bringing up a new thing in its instead of it. You should be bringing up a new one in its replacement. That does not mean that you should not do a root cause analysis on why it went wrong, but you shouldn't spend too much time. You should not have attachment saying, no, I will not remove this. I have special bandages around that. Whatever that you're doing for your VMs, it should be done as part of a pipeline which prepares it in general. Having said that, I do realize that there are some things which you cannot apply the cattle treatment to. For example, if you have a database running, then you need to be careful about the data. So in this case, Azure Managed Backup does the backup of the entire VM using snapshots, and you can use it using prescribed shared schedule. To get started with this, you need to use these extensions. If you're using Windows, you need the VM snapshot extension. If you're using Linux, then you have the VM snapshot Linux extension. The backup is saved to recovery vault, so it's available for you. You cannot back up specific files, or you cannot restore specific files or specific directories. It's the entire thing that you are restoring. So keep in mind that. Okay. The next is secure images. I know a lot of you, when you are starting off, when you're rolling out your virtual machines, you go to the Azure Marketplace, you search for Ubuntu, you click on deploy, and you just pick it up. On the Azure Marketplace, they make it fairly clear who the creator of these virtual images are. And if you want to submit your own market images, there's a certification process that goes through this. But there's still a very high chance of unscrupulous individuals or rogue entities building their own images with Bitcoin miners, as I said, as Vinayak mentioned. Your images might be having Bitcoin miners, or they can have some malicious software which can steal your data, right? So why do you want to expose your virtual machine to that risk? So instead of using the marketplace hosted virtual images, what you could do is you can take a trusted image. Let's take an official Ubuntu image from Canonical or any one of the officially vetted ones, and you build your own images. Azure lets you build your own images. You can patch it with updates. You can use HashiCorp Packer. HashiCorp Packer is as a tool for building your own images. If you click on this link later, you'll see an easy way to do it. So you can build your own virtual machine images, and you can deploy it in your own image gallery. So your workflow would be not to search for random marketplace images. I know that's what we do if you're doing an individual, but you should be using the images that were built by your own team, which has been vetted by your security team if you have one, and you should be using Packer to build your images, and you should be using those to deploy. The same goes with containers. You should always build your own Docker images. I would not recommend you to use publicly available Docker Hub images. Sure, use a vetted Docker Hub image as a base, but Azure has the Azure Container Registry where you can store your images, and this is a private registry, so you need to authenticate and you need to authorize before you can start using them. So other third-party individuals cannot maliciously inject images or have bad images in the container registry. You should also be scanning the images for vulnerabilities. The good thing is, as of recent, I don't have the exact date, Azure Container Registry will automatically scan your images whenever you push a new image to the container registry. It will scan your image and it will show you what vulnerabilities are there in the specific image. In addition to this, there are multiple third-party image scanners. If you're going for a paid solution, there's Aqua, there's Prisma Cloud, which was earlier known as Crislog. If you're going for an open source image scanner, there's Anchor, there's Claire. So all of these, they will scan your images and they will tell you, they'll make a list of what packages are there, what are the vulnerabilities that exist. And that if you're wondering what the difference between a paid and an open source one is, the paid image scanners usually have runtime image scanners. Like if your container does something bad, if it tries to, you can define specific policies, and if it does something bad, then it can block access to it. You can also have policies which state that if my container image or if my Docker image has X number of vulnerabilities, do not let it to be pushed into the container registry at all, which gives you an additional step of security. Okay. The next thing is Azure Key Vault. Azure Key Vault is, I really like Azure Key Vault. It makes it very easy to use it. So Key Vault is the managed solution from Azure for maintaining your secrets. When I say of secrets, you mean you can store your API keys, your tokens, your passwords. A lot of people just stop at that for Key Vault, but a lot of people don't know that you can also use your Azure Key Vault to store encryption keys. There's a mistake in my slide. It says second. The second says it stores API keys. No, key management is for encryption keys. So if you're encrypting your disks, you can generate encryption keys and you can store them. You can also manage your certificates, your TLS certificates. You can provision them, you can manage them, and you can store them. And when you're bringing up your virtual machines, you can make a reference to the path in your Key Vault where your API keys, your passwords are stored, so that you don't have to hard code your keys or into that. And the best thing is, like, it's very easy to use. You can also set up monitoring on that. You can send the logs from Azure Key Vault to your storage accounts or to Azure Monitor Logs, which is another managed solution from Azure. You can send your logs to your storage accounts, and then from that storage account, you can use your own SIEM tool like Splunk or Logstash or whatever it is that you use, and you can set up alerts around that. So you know if there's an unauthorized access to your Key Vault, you know that your account was broken into, and you can get around to remediating that. Okay, and like I said, Key Vault also integrates really well with the other Azure services. When you're provisioning a VM using the Azure Resource Manager, which is what ARM stands for, you can reference a Key Vault, and the ARM will fetch the secrets from that and use it to provisioning your VMs. It lets you use a managed identity to authorize and authenticate your VMs. So when you're talking about managed identities, I didn't mention it during the IM, but traditionally, the way of authenticating and authorizing is using usernames and passwords, right? When you do a login to say Key Vault, for example, you might be tempted to create what is known as a utility account, which is used for other miscellaneous utilities. You create a username and a password. The problem with this is that if you have a username and password, you still need to manage it and you still need to store it somewhere. Correct. So Azure lets you get around this by what is known as managed identities. So managed identities is basically a way of saying this specific service can talk to this other service, and it basically creates what is equivalent of a user, but for the service instead. So, and when you're using Key Vault with Azure Managed Service, your applications can fetch the secrets directly instead of hard coding them. So you don't have to hard code any API keys or any passwords as such. So these are some of my example guidelines for using Key Vault. Like I said, RBAC is your friend. Use the least privilege access principle. Do not give access to Key Vault. Key Vault is a very, very privileged resource, so be very careful. Use the least privilege access principle, where it's like, you will give access only if you need it, nothing else. Just because I will not be giving you access just because you want it. You need to have a proper, you need to have justification for that. Use VNet service endpoints. Service endpoints are endpoints which only the specific service can access to. I will be touching about VNet service endpoints at a later time when you're doing network security. Use a separate Key Vault per application per environment. This goes back to the same principle with subscriptions, where don't have everything stuffed into one. It defeats the purpose. Separate it out. Have one Key Vault per application per environment. If your application has dev stage prod, have dev stage prod Key Vaults. Key Vaults don't cost you anything extra to build. And you have the advantage of if a rogue script has gone wrong, the blast radius is limited. Key Vault has this option of enabling soft delete. So it means that when you delete a specific secret, it's not permanently, it's not wiped. You can maintain. It will make a. It will have. It will have it retained. You can define the retention period for how long it should retain it to. So this is equivalent to when you're deleting something from your database. You don't necessarily delete the row, but you just say you mark a flag which says deleted equals true. After the retention period is over, it does a purge where it actually goes ahead and deletes it. But be wary of this soft delete. I ran into this problem where I created a key vault and then I decided, sorry, not a key vault. This actually applies for key vault as well. I created a secret and then I deleted it. And then when I was trying to create that secret again, it just failed. It told me, it gave a very cryptic error saying that cannot create this. At least when I tried to create it, it gave a very cryptic error when I first tried it. Yesterday, when I tried this again, Azure has changed this response, so it tells you explicitly that this secret was soft deleted. So you cannot view or you cannot delete a soft deleted secret from the portal. Neither is it listed in the portal, but if you use the Azure CLI and assuming that you have the right credentials, you can go ahead and delete it. This is option called purge protection, where Key Vault will not let you delete until the whole recovery period, rather the whole retention period has passed through. So you can enable that as well. Purge protection is not enabled by default, so you have to explicitly enable it. And to purge, you have a purge is also defined as a privileged access. So you need another set of permissions for it. So just because you have delete access does not mean you will be able to purge it. So keep this in mind. Okay, so we've talked about a lot of things. What I'm going to do right now is I'm going to give a small demo on how we can use Azure Key Vault to fetch secrets without using without embedding any keys. Okay, right. So you should be able to see my screen. It should just say hello all, correct?
Yes, Satya, we can see your screen.
Yes. Thanks, Vinayak. So what I have right here is I have a very simple Azure functions. Now, all that Azure function does is, let me go back. So what I have here is a very simple Azure function. All that function does is it just returns, if you pass in the name parameter, all it says is hello all. So if you see this all, it's actually coming in from Azure parameter. So now if I change this to everyone, it says hello everyone. Now I have another parameter called secret. So if you pass the secret parameter, what it does is it will actually fetch the value from Key Vault. So if I say Azure, so it says I do not have that secret for you. That is because in my Key Vault, I just have one secret which says highway. So if I pass that, here's a secret for you, 100 unicorns. And this value is actually coming from the Key Vault. So you can see here, 100 unicorns. I forgot to mention, but your keys, the secrets and the keys in Key Vault are also versioned. So you can go back to a specific version or you can create a new version at any time. So just in case you've overridden your keys, it's happened to me. The versioning system has really helped me go back to my the value that I really wanted. So coming back to this demo, we have this secret which gets the value. So you can see that the secret value is fetched from this function called get secrets. Let's take a look at get secrets. This get secrets is actually from a file called secrets.py. So let's take a look at Key Vault. So what I'm doing here in this get secrets method is I'm going to use my Key Vault, which is H200 KB, which is a short for highway to 100 unicorns, but I just wanted to keep it short. So I'm going to fetch it from H2 100 KB. You can see my Key Vault here is H2 100, and I'm going to fetch that specific credential. Now we can see here I don't have any API keys. I do not have any secrets embedded. So how does this work? It comes down to this managed identity that I have created. So and I'm using the Azure Key Vault SDK. So when you say credential equals default Azure credential, this Azure what the Azure Key Vault SDK will do is it will go through. It's from the identity SDK, not from the Key Vault SDK. What it will do is it will evaluate what options you have provided. So I have not provided any client IDs or service principals, things like that. So it is going to default to fetching a secret, an access token, using the IMDS service, which is the instance metadata service. IMDS is basically an endpoint which is made available to almost all Azure resources. It's at a very specific IP. I think it's 169, 168, whatever is documented. I don't recall it on the top of my head. So it provides metadata service. So you can query it, and it can you can ask what happened to do I have any, what are the keys associated with this, what are the tags associated with this. In this case, what this SDK does is it is going to call that IMDS and ask for an access key, and in this credential the access key will be used. And so when you create a new secret client using the Azure Key Vault SDK, it's going to use that access key fetch provided by the IMDS service, and that's how it authenticates itself. Okay, and you can see the access policies. I have this application which I've configured, and I have said it's got only get and list access. So that is how you can define via RBAC. In this case, I've given it an application. You can also have it at a role level, and you can say. So that's how Key Vault, that's how this functions can fetch the secrets value from Key Vault. Okay. And you can see all of this happens transparently behind the scenes. You don't have to, like I said, for me, the biggest advantage of this is that I don't have to worry about maintaining API keys. I don't have to worry about maintaining client IDs, credentials, and whatnot. It's very simple, very easy to use, and you can use it with your VMs, not just functions. So yeah, that's about a quick demo on this. And let me go back to my slides. And you should be able to see my screen. So that brings to an end of the infrastructure part. We'll be going to network security, but let's take a quick break. Menak, if you have any messages and if you have any questions for me, let me know. I can try to answer them.
Yeah, Satya. There are actually a bunch of questions. So I think there were a bunch of questions on blob storage. So so basically, Anand Subhash says, suppose we store images in blob storage and give access to users based on criteria. That is, each user will get a unique link for him to access. So that was the first question. So I mean, you can do that by building auth on top, and this is possible to implement using functions. I'm just looking for the blog post for this. Anand will post it. The second question is, we have a scenario of using MongoDB, Elastic Data Store, and LevelDB running in a container or Azure VMs. I want my QAs to access, say, MongoDB through a client, say NoSQL Booster. Can I still manage this using Azure RBAC? How can we enable it on MongoDB?
Yeah, it's you have to define the roles. The roles and all. Like I said, there's a little bit of work that you have to do to set this up. It's not like it's a one-click or a one simple thing. You need to build the roles, the service principals, and you need to apply these roles and service principles to the applications. And once you've done it, it will be possible.
Yeah, and I think there were some comments on time-bound expiring keys. Even those are possible. So
Yes.
I posted a link to Azure Security recommendations where time-bound keys you can see, and
Yeah.
also Satya also talked about Azure Key Vault. So I have posted a link to that as well. Uh, I think
So
actually one more question. Sorry,
on
sorry.
the time bound, sorry, Vinayak, just to give a demo on the time bound, like Vinayak said, you should be able to see my screen. You can see you can set an activation date and expiration date. So you can say when it becomes active and when it becomes inactive. So you can say for a very specific period of time, I want this secret to be available, and after that, it should not be available at all. So you can do that. Definitely, you can do that.
Cool. Yeah, so this is super useful what Satya said for like key rotation, right? Key rotation policy. So you can push keys and rotate the keys. So that becomes really easy, right?
Mhm.
Because that is one of the key. We didn't talk about key rotation, but that is one of the security best practices that we have. One more question is we have used Azure Container Registry to store our Docker images and deploying containers in customer premises. Is there a way we can limit access to one specific container image?
Uh, I So I've not worked in depth with Azure Container Registry, but assuming that you can create multiple registries, or rather multiple repositories, I think it should be possible using RBAC to limit access to for that specific person to just that specific repository. I'm pretty sure it should be possible. I'm not explored it, but that's a good way to start around that.
Yeah, so I think so it can. What I feel is I think this customer is external, right? I mean, under knowing probably the use case. So you can do auth using Azure AD, and then you can use RBAC to map that to a user, and then give access to that very specific fine-grained resource. You are in this case a container image. You'll have to
Yes.
you'll have to experiment a little bit, like how do you exactly do it? But yeah, it is
Yes.
possible. It is possible to do that. Is there a maximum number of characters that we can use for a key in a key vault?
I'm not sure if there's any upper. I'm pretty sure there's going to be an upper bound, but I'm not sure if it's practical limit. We'll have to check the documentation. I don't have it on top of my mind.
Yeah, I
Uh,
think I'll answer that question. I think it's there in the documentation. I also don't remember off the top of my head, but I'll answer it. In the chat.
no, this we do use key vaults for storing our public keys, or rather our private keys, not public keys. We use it to store. I've used it to store a whole bunch of pretty large secrets. So there's bound to be an upper limit, of course, but when I like you said, I don't know at the top of my head what would be the upper bound.
Cool. I think with that, I think we can resume with the presentation.
Mhm.
Satya, I think just a time check with just above 5. So maybe we'll have to wrap up in another 15, maybe 20 minutes.
Oh, okay.
Yeah.
Yeah, sure. I'll try to. Network is something a bit difficult for everyone, but I'll try to summarize it so as fast as I can.
Cool.
But
Thanks.
let's go ahead. So network security. So all this while we talked about, right, which is good, but how do you prevent network access? How do you reduce network access? I mean, for example, you brought up a VM and you just click next, and next thing you know, you have anyone who's deployed a VM on anywhere, whether it is Azure, AWS, DigitalOcean, it doesn't matter. You are bound to get hit by bots sooner than you think. I'm not kidding. I'm not making this up. Just spin up a VM, open access to all, and see. You're bound for malicious activity. There are bots which are actively and at any time they're just opening up. They're just scanning random IPs, and your instance can be one of these random IPs, and they'll just do random waves of attacks and see if you're vulnerable. So the good thing is Azure, when you're building a VM, or rather when you're starting to deploy something, you start off at the most basic level. at a subscription as your logical container. A resource group is your next logical container. And for actually deploying resources, you get into VNets. VNets, excuse me, are RFC 1918 compliant custom private address space. In other words, this is a very private address IP address space just for you. And by you, I mean your workload. In You can consider this as an equivalent of in AWS. Its equivalent is a VPC. Even in your own home networks, right? When you set up your Wi-Fi and whatnot, you get an 198, 168, 192, 168, etc., etc. These are all custom private address spaces. Okay, so the way to go about when you're deploying something is you create a VM first, okay, and then you break up that VM into multiple you create a VNet first, and then you break that VNet into multiple subnets. Subnets are nothing but sub networks, just smaller networks within the big VNet. Why? Because then you can assign this VNet, you can assign these subnets into a specific purpose. You can say I have a subnet which is for my public access. I'll put my load balancers, for example, into that subnet. I will have another subnet which has got only outbound internet access. This is, for example, your application servers which are responding to requests. And then you put your database servers into a third private subnet, which has got absolutely no internet connection whatsoever. You can only, you're going to restrict access to that subnet from, from your application servers. These are sort of, now these, at least to me, these are considered as a standard way of splitting up your big VNet. But to a lot of people, this is a lot of voodoo or black magic. Because of time constraints, I will not be able to tell you exactly how you do it. There's a lot of good documentation on the Azure portal. Go for it, look for it. But always, the same principle as with a subscription. Do not put all of your resources into one big subnet. Give it public access and hope and pray that nobody's going to break in. That's not going to happen, unfortunately. You might be wondering, why would people attack me? I am no one. People don't know, or they don't care who you are. All they see is one public IP, and I'm going to hit it. And what I can get from that public IP is good. And you can think about the retroactive effects, right? You deployed something long back, now it's open for public for all. Now you're 2 years later, your service has gone big, but that one single VM is still there, which has got public access. And yeah, someone tries it, they get it, and voila, you have a data breach, right? So coming back to this, you break into subnets. Each of the subnets, you can scope it to VNets. You can say that this subnet can have access only from this subnet. So you don't have you are further limiting access. The good thing about Azure VNets is that by default, your outbound is unrestricted. So if you bring up a VM and you're trying to update the system, there's no security groups or there's nothing preventing it. But by default, inbound communication is not allowed, and it is only via a standard load balancer or a public IP, either of which you need to explicitly say. So this is good because when you're bringing up a VM, if you just go click, you will have a VM which you yourself will not have access to because it is accessible only from within that VNet, but it will not be accessible from the public spaces either. So it's a net, it's a good thing. Okay, so some guidelines around VNets, and I've dealt with a lot of VNets during my course of career, and there's some general guidelines. Don't have overlapping address spaces. If you're bringing up multiple VNets, and I know you would be, don't have overlapping address spaces. When I say overlapping address spaces, I mean don't have, say, one VNet which is having a couple of IPs in common with other VNet. Why? Because if and when you need to bring up VNet peering. VNet peering is a process where you have one VNet and you have a second VNet, these are isolated, but you need the workloads in either of these VNets to talk to each other. So now when you peer them, if you have an address overlap, then how are you going to route the packets? If you send up, let's say that there is a address space overlap. Let's say that 192.168.10.10 is there on both these VNets. Now you peered them, and now if there's a packet going to 10.10, which where should it go to? So Azure will not agree to peer them at all, if I'm not wrong. And you basically have two VNets, and now you need to resize these VNets. Now you cannot resize the VNets just like that. You need to remove everything and you need to recreate them. So that's why these first two guidelines are there. Don't have overlapping address spaces and reserve some space for future. Just because your application is small doesn't mean you give a very small subnet. Conversely, just because your application is small, or just because you can't be bothered with setting up the subnets, or just because you don't want to set up the subnets, doesn't mean you have one big public subnet. If you want to move your workloads into, if you're getting more private or more sensitive data workloads and you need to move them and you can't because you've run out of space, then you're in a bit of trouble. Okay. You can filter traffic with network security groups to subnets to limit access. I'll talk about network security groups in the coming slides. So you can filter and you can say, I want access to this VNet from only those resources from these specific network security groups, or only from these subnets. So you can sort of here restricting access, so who can access your workloads. And like I said, communicating to other Azure resources, you can have VNet peering to have to have conversation, to have traffic with other VNets. You have Azure Service Endpoints, which are private endpoints in the sense that these are not these endpoints are the traffic going to these endpoints are not over the public internet, but via private endpoints. So your application can talk to, say, the blob storage or a private service endpoint, and this will not be over the internet. Plus, on the benefit is that you also save on some S0 problems. You can also set up a VPN or an express route. Express route is basically, I think, you can have a specific route from your on-premise service or from your on-premise data center to within Azure, so that this does not go over the public internet and it goes via your secured routes. The next thing is network security groups. Basically, these are rules which let you specify what you want to do. Think of it as a big gate. And you can say, think of it as like a gated society. At your gated society, you will have security guards. The security guards will ask you where you're coming from, where do you have to go to, and it will look up what permissions and privileges are there. And if they say that I don't see an option for you to let you in, then they're not going to let you in. It's something similar. You can have multiple rules. These rules are evaluated on the basis of this combination of which source port it is coming from, where it is going to, which destination port it is going to, and what protocol. So you can have a security group which says any SSH coming in from a specific IP. It might be a home IP or it might be an office IP. So that IP becomes your source. The port 22 for SSH becomes your source port, and it says anything which is going towards a specific VNet or a specific subnet, that becomes your destination. The protocol will be TCP, and you build your NSG like that. And it's important to remember that the rules are stateful. So if you have an outbound traffic initiated from a VM, you don't need to specify a specific rule to allow that traffic to come via inbound. In contrast, on AWS network ACLs, you need to specify both an inbound as well as an outbound rule. But then in network security groups are equivalent to security groups, so you don't need a corresponding inbound rule if your outbound rule is there. Okay, so when you create a new network security group, these are the default rules for inbound. It says it lets you traffic from any VNet, and it can be on any port from 0 to 65K on any protocol. It lets traffic from any load balancer. Okay, any load balancer, any Azure load balancer to be specific. And again, the same port, same protocol, and then it denies everything else. So what this means is that if you're trying to SSH in from an internet, and if you have not set up network security group, or rather if you're not set up specific network security groups, your SSH will fail because the traffic is not coming from a VNet, right? Because it's at the VNet level. It is not coming from a load balancer. It is coming from the public internet. And so it is going to hit the deny all rule, and it's just going to ignore it. By default, like I said, the outbound rule is just let anything on any port go through, which is good or bad depending on how you take it. It's good because you don't have to worry about debugging why this connection is not going through. But if you have any malicious applications, then that can automatically send data out. So that's why I said you should be specific about the rules that you're building. So firewall, a lot of you are familiar with firewalls. Azure Firewall is nothing but a managed firewall service. It lets you apply filtering rules, and it can apply filtering rules on a FQDN, which is a fully qualified domain name. So you can say anything coming from this domain, I can reject it, but anything coming from this specific domain, I can allow it. So if you have API traffic, if you want your firewall to allow only API traffic, which is coming from api.example.com, you can apply a firewall rule which says allow traffic from api.example.com, but not anything else. And you can also have inbound filtering on HTTP or HTTPS along with the other protocols, which is RDP, SSH. So you can build up a very one of the things about cloud security is what we call as a defense in depth principle, where you don't just build one wall, you build multiple layers, and it's like you build layers over layers. It's just so that in case you have a breach, if it breaches at the first level, you still have multiple layers. So you can apply Azure Firewall as your first level of defense, and then you can chain it with network security groups for your defense in depth approach. The next one is something just-in-time VN access. This is something which came in very. I think it's still in preview, or I'm not sure if it's available GA. I think it's just check, but this is very cool. What it does is, I said that you can allow access to NSGs, but what if you don't want to do that either? What if you want access on a on-demand basis? So this is what just-in-time VM access does. So basically what it does is it locks down access by default to the NSGs. And when you say, I want access, you click a specific link or you make an API call, and you can say, okay, this access is allowed. So Azure will automatically check if you have the RBAC permission. Azure will automatically modify the NSG group. Rather, it will automatically modify the NSGs to allow traffic. You have a specific time period for which it is allowed. So if when the access time is done, it will automatically revoke access to it. It's important to note that existing connections are not interrupted. So be wary of that. Just because, so you're most likely not going to get kicked out if you have SSH keep alive enabled. But if you don't have keep alive, and if you have remained idle, you're going to get interrupted, and you won't have access, and you have this. You can request for access again. This is you can think about it as very cool, because now you can let's say that you don't want your TBS to have access to the VMs all the time. But just in case of emergency maintenances, or in case you want to do some debugging, you can use this just-in-time VM access, and you don't have to worry about maintaining the rules and whatnot. So just whenever they want access, enable this, let them do their work, and once it is done, Azure will automatically revoke access. So how do you revoke access? There are different ways of accessing. Rather, how do you gain access? You can request for access via the Azure Security Center. On the VM page, you have an option to click and say enable just-in-time VM access, or you can also use via PowerShell or API commands to enable access to this. Azure Service Endpoints, I touched on this, but just to reiterate, like I said, if you have traffic going over public IPs to specific Azure services, then you need to whitelist this. You need to have complicated security group rules. But instead, with Service Endpoint, what it does is it switches to private endpoints, and then you can apply endpoint policies. So with endpoint policies, you can say that, say for example, for my blob storage, I will allow access only coming in from very specific from only very specific subnets. So you don't have to worry about maintaining complicated security groups rules. The thing is, the more complications you have in terms of security group rules, the easier it is to ignore it completely, because it's like it's too complicated to review. We're not going to look at it. So yeah, this is a better way to do that. There are some gotchas with service endpoints. For now, only Azure storage services are supported. No other managed service is supported. That's because of the way Azure needs to apply the rules and whatnot. You cannot apply service endpoints for traffic coming in from on-prem to Azure. So with service endpoints, you can say, I want this specific blob service, blob storage account to have access from this specific subnet, but you cannot say this blob storage must have access only from within from this specific on-prem. You cannot apply that using the service endpoint policies. I mentioned this, that classic storage accounts are not supported, but I'm not sure how relevant it is anymore, because the newer storage accounts have been in place since quite some time now. But still, just in case you are using these classic storage accounts, they are not supported. The last bit is this is sort of a one-stop look if you want to improve your security coverage. Azure Security Center is where you should be looking at. It's a unified security management system for Azure, and it lets you improve your security by reviewing and configuring recommended controls. And if you heard that, when that is right, Azure will automatically give you recommendations. Let me give you an example. This is a screenshot from Azure's documentation. I'll give you a small demo as well as to how my subscription looks like. But since mine is a private subscription, I don't have any workloads, you won't see a lot of recommendations, but they're still there. Nonetheless, you can see from an overall point of view what you can do, what recommendations you can apply. Of course, it's up to you to apply or ignore them completely. I will not be getting into a deeper in-depth session on Azure Service and Azure Security Center for now, because that can take quite some time. But yeah, know that there is something called Azure Service and Azure Security Center. There are different tiers of access, so take a look at that. And just to have a quick demo of how it would look like. So you should be able to see my screen. It's still looking at Key Vaults, but you can see Security Center is available here. Otherwise, you can just go here and click on the Security Center. So I don't have a lot of workloads. I just have this couple of Azure functions, couple of identities, and VMSs. But nonetheless, you can still see it gives you an overall security score based on what. So don't take this points as an absolute measure. Don't compare this point saying that, hey, I have 100 points. How much do you have? My 35 points can mean that it's more secure than your 100 points. It depends on what workloads you have running. Okay, so you can see you can look at a severity level: high security, medium security, low security. You can look at threat protection. There's a lot of things that you can look at, but just if you look at the recommendations, now you can start deep diving in. It says enable MFA. Although I do have MFA, it's for some reason it does not detect it as having MFA. I'm not sure why, but I'll bring it up with Azure team at some other point. But you can see it goes to extremely detailed levels. For example, it says that function app should only be accessible over HTTPS. Although I am accessing on HTTPS, my function is still available on HTTP, which is not secure. Right? There you go. So I'm running a plain old HTTP endpoint, and I can still fetch my secrets. So if anyone can intercept this, they have my secrets. So that's why Security Center says this thing. And it's got a quick fix feature also. If you just click on fix, and it will tell you where and all it should be applied on. And just say remediate. And it will just say, it gives you a warning saying that if you have a custom domain, then your SSL cert should also be updated. But since I don't have a custom domain, I'm just going to say remediate, and it should be, it'll take, yeah, that's it done. It'll take some minutes for it to be active, so we'll not look in that. But you can take for, you can assume that it's been applied. So yeah, there's a lot of other features that you can do, and you can also go on a category basis. You can go on compute, on VMs, on VMSs. So you can see I have a VMSs where I don't have diagnostic logs enabled. So it says that diagnostic logs should be enabled so that if something goes wrong, the support team can check and see why it's going wrong. And I was talking about just-in-time VM access. So this is where you can enable it. It says just-in-time, because the just-in-time needs the specific agents to be installed. Otherwise, it won't work. But regardless, it's a good thing to have. In terms of networking features, you can say it says secure transfer to storage account should be enabled, and I don't have any, so very good. So yeah, this is just the getting to the start of it. There's more that you can take a look at. So yeah. And yeah, that comes to the conclusion. There's a whole bunch of resources. Vinayak, we are sending these slides over, right? If not, you can just click on this.
We are actually sending these slides over at the end of this.
Yes.
Yeah. So we have. I mean, we had a few questions and I have answered them. We're almost out of time. And I think one of the challenges when me and Satya were talking was that security is such a large, I mean, Azure itself has lots of services, and to secure each of them is such a large, but we wanted to kind of hit on the basic principles that kind of adhere and, give you the tools, like for example, Azure Security Center, the Key Vault, and also to do a little bit of demo saying that, some of these things are not really hard. They have to be followed through. And if you kind of follow these principles, it will be possible for you to be secure by default.
Yep.
And yeah, Satya, can you please stop sharing your screen? And we will also quickly announce the winner of the social media center as well. I hope you found this very insightful. I mean, I know we had to cover a lot of ground. We had to cover infrastructure. We had to convert network security, Key Vault. But I think there is enough that gives you a sense of what is possible to do in Azure Security. What we'll do is based on this start, we'll probably have more deeper sessions on each of these aspects. Like for example, as Satya said, just the network security by itself, you can do a workshop for like almost 3 hours just on the very specific aspects of it. Turning the knobs, how do you kind of design VPCs, how do you kind of enable access, how do you route traffic between them, how do you have a bastion host. So it's a fairly large area. So what we'll do is post this, we'll probably have Satya back hopefully at one of the later sessions, and we'll do in depth of each of these, and similarly for I think Key Vault and other aspects also we'll have more deeper webinars on that. So as you can see on the screen, we have the winner of the social media challenge. We Anand Subhash. You are the winner of the swag bag from Microsoft for Starters. So we'll soon get in touch with you, and we'll post you the swag bag because of COVID. I think it might take a little bit of time, couple of weeks more, but we'll get through to you and we'll get in touch with you. I hope you found the webinar interesting, and thanks Satya for this detailed overview. And the demos were very interesting, and I think from the questions as well as the interactions, I can see that you have enjoyed it as well. Yeah, you can actually also answer the poll. It has been pushed again by Kabir, and let us know how any feedback about this. And as I said, like we will have more deeper sessions soon. So thank you all. Thanks for your time. I know it's been like 1.5 hours, but it has been quite action packed and with lots of nuggets of information. So there will be a lot of takeaways from this. So see you again soon next week. We will have another webinar in this Scale Up Saturdays, and soon in the technical series we have a session on cost management and reducing costs on Azure, which is actually very, very important for this time because everyone's looking to reduce costs. So I will see you again in the next version of the Scale Up Saturdays. Thank you, Satya. Thank you, everyone. Have a good day.
Thank you, Vinayak. Bye-bye.
Thanks. Bye.